In this video, we are going to see about pulse code modulator. Introduction. Pulse code modulator, that is PCM, is a special form of analog to digital converter. It consists of sampling, quantization and encoding steps. It is widely popular because used for a long time in telephone systems. Inexpensive electronic exists. Error can be corrected during long awful transformation. Can use time division multiplexing. This is the block diagram of PCM, that is pulse code modulation. We have PCM transmitter where we can convert the analog to digital conversion, and next we have the receiver block in bottom, which is used for converting digital to analog signals. First, the analog signal input is given to the low pass filter, and then from the low pass filter and the input is given to the transmitter block, where the transmitter block consists of instantaneous sampler and hold circuit, where we can take the input sample by sample and hold it one by one, and then we can transmit to the other block. And next we can give it to the quantizer, and then the signals are quantized and then given to the encoder block. This instantaneous sampler and hold block, quantizer block and encoder block together can be termed as PCM transmitter block. And then from the transmitter block, that is encoder block, we can get an output of PAM signal, that is pulse amplitude signals. Okay, and then we give that input to a regenerative repeaters, and that regenerative repeaters may be the telephone lines, where I have given there telephone lines. Regenerative repeaters, we have 3 blocks, that is channels, where we can transmit the signal from through the telephone lines to the receiver block. Receiver block, we have a regenerative circuit block, where the PAM signal is regenerated as PCM signal, and then it is given to the decoder block to decode the signal from digital to analog signals, and then it is given to the low pass reconstructed filter, where the noise has been rectified in the low pass filter, and then output is given as analog signal output. Here the analog signal is given as output, and we have generated a digital output in the PAM signal, and then that digital signal is transmitted through the telephone lines by using a regenerative repeaters, and then the using regenerative circuit, the waveform has been converted to digital form, and then it is given into input of decoder circuit, where the digital signal is converted into analog, and by using low pass filter the noises has been reduced and the analog output has been received. Effects of noise. Types of noise we have is that quantizing noise, environmental noise, filtering noise, that is low pass filtering at a decoder. Low pass filter is used for reducing the noises. Types of quantization noise. Overload noise, where input is too large, we have overload noise. Random noise, when input is very small. Then is gradual noise, and is hunting noise. Special quantizers are used, where is mu, that is law, A is equal to law quantizer. Peak signal to noise ratio can be calculated, where S by N of peak out is equal to 3m square divided by 1 plus 4m square minus 1 into PE, which is equal to 3m square, where PE is negligible. Average signal to noise ratio is measured by S by N of out is equal to m square divided by 1 plus 4 m square minus 1 into PE, which is equal to m square. where PE is negligible here. M is quantization level and PE is probability of bit error in the channel. Let M is equal to 2 power n. We have S by n of out is equal to M square, which is equal to 2 power n the whole square. That is equal to 2 power 2n. S by n of dB, that is bandwidth, which is equal to 10 log of S by n, signal to noise ratio output, which is equal to 10 log of signal to noise ratio, where we get this, what we get is 2 power 2n, which is equal to 20 n log of 2. The value will be 6.02 n. Next, bandwidth of PCM. Assuming W of t is band limited to B Hertz. Minimum sampling rate is equal to 2B samples per second. Analog to digital converter output will be of n bits per sample. Assume a simple PCM without redundancy. Minimum channel bandwidth will be of bit rate per 2. Bandwidth of PCM signal is B PCM is greater than NB with sign functions as orthogonal basics. P BCM, whereas it is greater than or equal to 2NB with rectangular pulses as orthogonal. Thank you.